So we talked about the different types of compounds, molecular compounds and ionic compounds, and how to identify those. Now we're going to look more specifically at each of those, and we're going to start with the ionic compounds. So remember, an ionic compound almost always has a metal element in it, but there are some exceptions. And we need to understand how to figure out what charge an ion of a given element would have. And we went over that yesterday as well. So there are ions with predictable charges. The ones we looked at yesterday are main group metals. So in groups 1, 2, and 3. So the metals in group 1 have a +1 charge. In group 2A, they have a +2 charge. In group 3, they have a +3 charge. So nice correlation there, right? There are two others that you just kind of have to remember, and those are zinc and silver. And I'll show you on a periodic table in a minute how you can remember those. Zinc is always +2 and silver is always +1. For the nonmetals, there's a couple of different ways that you can figure out the charge. You can say the charge is equal to the group number -8, or what most students prefer is just count back from group 8A. So start at the noble gas and count back, and however many spaces you go back, that's the negative charge in the ion. So in an ionic compound, we always have positive ions and negative ions, because you need opposites to attract. And the sum of those charges has to add up to 0, because the compound itself cannot have an electrical charge. It has to be electrically neutral. I need a periodic table here for that other. Let's find one. Okay. This periodic table is about something else, but we can look at it for this. So I just want to go over those ions. So group 1A, those are 1+ ions. Group 2A, metals, 2+ ions. Group 3A, 3+. And then we've got zinc and silver. So this is how I learned to remember this. Here's aluminum. What's the charge on an aluminum ion? It's 3+ because it's in group 3. Okay? And so I look at these, and this is like going down steps. Aluminum, zinc, and silver. So this is 3+, 2+, 1+. So zinc's always 2+, and silver is always just +1. So aluminum, zinc, and silver. Any questions about that? You just have to remember those. Let's get back to where we were. Nope. So when we're writing formulas for ionic compounds, we're going to write the symbol for both ions with the charges so that we can see what we're looking at. I don't advise doing this in your head. Actually write it down. And then what we need to do is, this is what's called the crisscross method. So take the magnitude of each of the charge on each ion, and that becomes the subscript for the other ion. And then you need to check and see if you can reduce those subscripts to a lower ratio. And then you should always check to see that the sum of the charges exactly cancels the sum of the charges. The sum of the charges of the cations exactly cancels the sum of the charges of the anions. So let's do an example here. So we're asked to write a formula for a compound that forms from strontium and chlorine. So we need to find those elements in the periodic table and identify what their charges are. So strontium has the symbol Sr. Where is it on the periodic table? What group number? Group 2A. So what does that tell us about the charge on a strontium ion? It's got to be 2+. So that's the strontium ion. Chlorine is Cl, bless you. What's the charge on a chlorine ion? -1. All right, so we don't write the 1, but there we go. So the crisscross method which is what most students like, is you take this charge, and that becomes the subscript on the chlorine, and you take this unwritten 1, and that becomes the subscript on the strontium. And so you get SrCl2. It's just a trick of this crisscross method. But let's maybe do another example. So if we had Fe3+, bless you. Oh no, that's not a bless you thing, is it? I'm sorry. I got more sleep last night, but I'm still a little punchy, I think. Okay, just bear with me. Okay, so if we're looking at these two ions, and we do that crisscross thing. So the 3 comes down here, the 2 comes down there. What do we end up with? Fe2S3, right? The students like that because it's just a little trick thing. Yes?
What happened to the negative on the SR?
That's a good question. What happened to the negative and the positive signs? So let's look at what we're actually doing here, and I think that'll explain why we just kind of left those signs out. So let's do a different way of thinking about this. So we've got strontium has a 2+ charge. Chlorine has a -1 charge. In the compound that these form, the charges are going to add up to 0. So if we have one of each of these, the total charge on this one is +2, and the total charge over here is -1. Do those add up to 0? No. We need +2 and -2. Well, how could we have -2? Well, maybe we need 2 of these. So if I throw in another chloride ion, now what's the total charge of those 2 -1 ions? -2. So now we've got +2 and -2. Do those add up to 0? Yeah, they do. So then when we're writing the formula, we've got 1 strontium and 2 chlorines, and we get this guy over here. Is this stunned silence, or what is this? Did that make any sense? So the total charges have to add up to 0, okay? The crisscross thing is just sort of a shortcut that works most of the time. This is the thinking about it, understanding what's going on. If you're good at math, what we're doing is we're looking for the least common multiple. Remember what that is. Let's look at iron and sulfur here. I didn't leave myself much room. I'll squeeze them in over here. So Fe3+ and S2-. So the total charges, we've got +3 and we've got -2. We need to get those to be equal. We need +3 -3 or +2 -2. The actual number doesn't matter so much, but they need to be equal. Okay? Well, we can't just change the number. We can't change the charge. But we can throw in more of one or the other ion. So we don't have enough negative charges. So let's draw in another sulfur. Well, that brings the negative total to -4. Now we've got too many negatives and not enough positives. So the only thing we can do is add more. So we'll put in another iron, and now that gives us a total positive charge of +6, and we start to feel like we're running in circles, right? So we've got a total of +6 and -4. So now we're short on this one. Oops. So let's put in another sulfur. And that brings us to -6, and oh, look, we arrived. We got the total positive and the total negative charge to add up to 0. Question?
Why is iron
That's a good question. I probably shouldn't have used this one as an example. I'll explain that in a couple minutes. It's a good question. So then to write the formula for this, we have 2 irons, so that's why this is Fe2, and we have 3 sulfurs, and that's why it's S3. Any questions? Which one do you like better, doing it this way or doing the crisscross thing? Crisscross thing, yeah. So let's write the formula for the compound that forms from aluminum and nitrogen. So aluminum is Al. What charge does an aluminum ion have? 3+, because it's in group 3 in the periodic table, group 3A. And nitrogen is N. And what charge would that have? 3-. So if we just do the crisscross thing, what would we end up with? We get Al3, N3. We can reduce that, right? Because this is a ratio of 3 to 3. That can be reduced to a ratio of 1 to 1. So that's what the instructions a couple slides ago told you to do. The other thing you can do that I recommend before you start crisscrossing is just look at the charges. 3+, 3-. The number is the same. So if we just push these 2 guys together, their charges add up to 0. So we could just write Al, N, and then we don't need to worry about reducing the ratio. But you can crisscross and then recognize that you need to reduce the ratio. Any questions? Yes?
I'm still confused on what the negative 3 comes from.
Okay, so where the negative 3 comes from. I misunderstood your question earlier. So on the periodic table, do I have a periodic table somewhere coming up here? That's lame. I need to fix these slides. Okay, periodic table. So here's nitrogen. For the nonmetals, the way we predict the charge is we're going to find the element on the periodic table. So here it is. And then we're going to start over here, and we're going to go -1, -2, -3. That's the shortcut, get the right answer with minimal thinking approach, which I think most of you would prefer, right? Does that help? And so that's how you do all the nonmetals. And the nonmetals are the ones on the upper right corner above that stair-step line. Question?
That was kind of my question. I was going to say, is it like that for like any one of them?
It's just for the nonmetals. The nonmetals make negative ions. And so you count backwards here. But this line here is where you stop. You can't go past the line. On the other side of the line, these are the metals. The metals make cations. And so for the main group elements, group 1A is +1, group 2A is +2, group 3A is +3. So aluminum's +3. What's the charge on zinc? +2. And on silver? +1. And you just have to remember those 2. Okay? We're going to talk about the rest of the metals in a minute.
Are the transition metals neutral? Or?
No. The transition metals, the rest of these guys in here besides zinc and silver, they form more than one ion, and so they're extra squirrely. That's why we're not talking about them just yet.
So for group 3A, as far as boron, since it's a metalloid, is that still categorized with?
That's a good question. So here's boron. I haven't seen this in print anywhere, but I haven't really seen any exceptions to it either. So what do you do with the metalloids, the ones that are adjacent to this stair-step line? My experience has been that if it's on the nonmetal side of the line, that it gets treated as a nonmetal when we're talking about naming things. And if it's on the metal side, it gets treated as a metal. So you would treat arsenic and silicon as if they were nonmetals, even though they are metalloids. The thing about boron is it does not make ionic compounds, and so we're not ever going to have to predict the charge on it. So these guys in the middle, we don't really talk about those, but they're not going to show up in any of your problems either.
You're saying that zinc has 2 plus 2 and then copper is plus 1, so what would be nickel?
Zinc is plus 2, silver is plus 1. Nickel, it depends on what book you look at. Some books tell you to memorize nickel, that nickel's always plus 2. Other books say, no, there are other ions. And so we're just going to go with what your book says, and we just need to memorize zinc and silver. And I'll teach you how to do the other transition elements in a couple minutes. Any other questions? These are good questions. Let's see. I did that one. Okay. So we talked about putting parentheses around these groups. And I said it was like, buying a bundle pack at Costco. So this is what those groups are. They're polyatomic ions. Poly is a prefix that means many. And so these are many atom ions. They are ions that have many atoms in them. They're groups of atoms that are stuck together, chemically bonded, and have an overall charge. And one of the challenging things about this introductory level class is we can't really tell you the whole truth because it would take way too long. And you probably don't want to hear it anyway, right? So we kind of lie to you a little bit. So some of this stuff you just have to believe me because the explanation is too long. So these are called polyatomic ions. And thankfully for you, this chapter is not on today's exam. These are things that need to be memorized. You don't need to memorize all of these, but I will post a list for you today so that you can get started on it of the ones that you do need to memorize. So acetate is the name of an ion. This is its formula. Why is this formula the way it is? Why is it named acetate? Well, the formula being the way it is a very, very long explanation, so can't do that. Why it's named acetate is because that's what we decided to call it. There's no reasoning it out. There's just, why is my name Jody, and how do you remember that? Well, that's what my parents called me, right? That's what they put on the birth certificate. How do you remember it? You just have to remember it, right? Unfortunately, with these guys, you can't just say, hey, you. They don't answer to that. So this one's carbonate, hydrogen carbonate, hydroxide. Some of these we need to remember, and some of them I'm not going to make you remember because they don't show up very often. But for now, we're just going to look them up in the table, okay? So if we need to write a formula for a compound between calcium ions and nitrate ions. So nitrate, you won't find that on the periodic table because it's not an element. It's one of those polyatomic ions. And a clue here is most of those polyatomic ions end with ate or ite. If we go back and look at this table, look at the endings of these. 8, 8, 8. That one's weird. 8, 8, 8, 8, 8. Right? That one's weird too. But most of them are ate or ite. So if you see something ending in ate or ite, you should think, that might be a polyatomic ion. Let's just go look that one up. After you memorize them, you'll look them up in your head. So nitrate is this guy, NO3 minus. And we need to copy that down exactly because there's another one, NO2 minus, that is nitrite. And those are different. So nitrate ion, we need the formula for the ion with its charge. And then calcium. What's the symbol for calcium? Ca. And what's the charge on it? 2 plus. Because it's a metal and it's in group 2A. Metals in group 2A have a 2 plus charge. Now we look at the charges here. This is +1 and -1. That's not +1. That's +2. +2 and -1. They're not the same. So we can do the crisscross thing. So we take this, and that becomes the subscript for the nitrate. We take the unwritten 1, and that becomes the subscript for the calcium. So calcium with an unwritten 1, NO3, and the subscript is 2. Now that's not confusing at all, right? Is that NO3 2 or is that NO32? This is why we use parentheses. Because otherwise it's going to get confusing. This tells me there are 2 of these nitrate ions. The nitrogen and the 3 oxygens come together. They're a package deal. You can't split them up. They come together. So I put shrink wrap around them, parentheses, and on the outside I say, how many of those packages do I have? Any questions? Mm-hmm.
If you're going to calculate like masses, right, would you multiply that by 2 if you're calculating that?
Yeah, there was that page on the last page on worksheet 4, which is a worksheet I don't usually assign, and so I wasn't aware of this until during lab. That last page is actually something from the end of chapter 5. We haven't gotten to how you calculate the mass of the formula yet.
Yeah, that's what I was asking. It was on there last night.
Yeah, yeah. So if you struggled through and finished it, you're ahead of the game. If you didn't finish it, you're okay still. So we'll get to that one in a minute. Any other? Yeah.
Yeah. When it's if the charge is positive, you don't put it. But what about when it's negative?
So when we've got the subscripts down here, we don't write the charges down there. Because you can't have -2 ions, right? You can't have, it's like you can't have -3 people at your party. How does that work, right? So when it becomes a subscript down here, we don't write the sign. It's always going to be a positive. This is a 1- charge on the nitrate ion, but when it comes down here to be the subscript for calcium, the subscript is telling how many calcium ions. And we have 1 calcium ion, not -1 calcium ions. Is that what you're asking?
Yeah.
If we draw this out, we've got calcium 2+ and NO3-. The formula is telling us we've got 2 of those. So if we add up the charges, this adds up to +2 and this adds up to -2. And so the combination of, bless you, 2 of these and 1 of those will give us a neutral compound. It has to be neutral. Any questions? This is the formulas for ionic compounds. A lot of students struggle with this. Keep asking questions. You are all capable of understanding how this works. It's just weird and strange. And when you're confronted with something weird and strange, it doesn't make sense at first. And so you have to keep asking questions. It's like learning to play a new card game, right? They can explain all the rules to you, and you're like, oh, you're just saying all these words. I have no idea what you're saying. It's not until you start playing the game and the other players say, no, you can't do that. You need to do it this way. And you make mistakes and people correct you, and after a while, you're like, okay, I see how this works now. And then you can play and you don't even have to think about the rules. Have you had that experience? I hate learning a new game. It's hard. But once you get used to it, once you learn the rules, it's fun. Unfortunately, with this, most students, even once they get the rules, they don't think it's fun. Whatever, we still have to learn it, okay? So keep asking questions, and that's why we need to work on the worksheet in lab so that I'm right there and you can ask me questions. You can ask each other questions, you can explain it to each other, and we can get this firmly in our brain what this is. This is an important part of the class. If you don't learn how to write formulas for ionic compounds, it's going to be really hard to pass. So Like if you can't calculate the average atomic mass of an element from the isotope values and the percentages and stuff, you could still pass the class. That's not a big deal. It's in chapter, whatever that was, chapter 4? It's in there. It's not going to show up again. This is going to show up throughout the rest of the course, okay? So this is super important. Let's see. Oh, good. We've got another example. Compound that forms between aluminum and phosphate ions. So aluminum. What's the charge on an aluminum ion? 3+. Because it's in group 3. Phosphate ion. Well, you see this ATE on there, and that should make you think, that might be one of those polyatomic ions. I'm going to look it up in my head and save us from scrolling through all those things. It's PO4, 3-. So look at the charges on these two guys. Do we need to do any crisscrossing or multiplying or anything? No, because if we put this one with this one, the charges will add up to 0, and that's what we're trying to get. So the formula is just pushing these two guys together, AlPO4. I don't put parentheses on this one because they're not necessary. You only need the parentheses if you have more than one of these package ions, these polyatomic ions. If there's just one, it's not confusing. If you put parentheses when you shouldn't, I won't mark it wrong, but I'll scribble them out because it looks silly to me. Sometimes students are like, why are we so picky about this stuff? We don't want to put any more extra numbers or parentheses or junk into these formulas than we need to. We want it to be as clean looking as possible. So we're not going to write the parentheses unless we need to. We're not going to write a subscript of 1 because it's not necessary. Okay, so we're trying to be concise. Unfortunately, that's sometimes confusing to students. Any questions about this example? Compound that forms between sodium and sulfite ions. What's the symbol for sodium? Na. Good, you guys have been studying. What's the charge on a sodium ion? What group is it in? It's in group 1A, so it's 1+. Okay. Sulfite. So this is not an 8 ending, it's an ite ending. If you come to the exam next week and you forget what that is, well, the sulf comes from sulfur. And almost all of those ite and ate things have oxygen in them. So it's going to be some combination of sulfur and oxygen. So that at least gives you a place to start guessing, right? Because if you don't know what the answer is, take a guess, right? Sometimes there's enough stuff that your brain has absorbed from lecture, from worksheets. You might not consciously be able to explain why you think that's the answer, but your subconscious is telling you, SO3. It isn't yet because you haven't studied that, but that's what my subconscious says. It's SO3 2-. Why? Because there's no great reason, trick, or anything. You just have to memorize it. I'm sorry. So we got that. How do we put these two together? So we could crisscross. We could take this unwritten 1, becomes the subscript for the sulfite. This 2 becomes the subscript for the sodium. Because this is 1+ and 2-. The numbers are different. We can't just push them together because they won't add up to 0. So we can crisscross. We get Na2SO3. 2 sodium ions, 1 sulfite ion. I don't need parentheses here because this is not a polyatomic ion. It's not a package deal. It's just an individual monatomic ion. Any questions?